Are you ready to dive deep into a cryptographic marvel that's set to redefine our digital world? Imagine proving something is true without revealing anything about the underlying information. This isn't science fiction. It's the power of zero-knowledge proofs, or ZKPs, and they are already here, fundamentally changing how we approach privacy, security, and efficiency in the digital age. At their core, zero-knowledge proofs are a revolutionary cryptographic method. They allow one party, known as the prover, to convince another party, the verifier, that a specific statement is true, all without disclosing any information beyond the validity of the statement itself. Think of it as demonstrating, a secret, without ever telling anyone what that secret is. This concept hinges on three fundamental properties: completeness, soundness, and zero knowledge. Completeness ensures that if the statement is true, an honest prover can always convince an honest verifier. Soundness guarantees that a dishonest prover cannot convince the verifier of a false statement. Most critically, the zero-knowledge property means the verifier learns absolutely nothing about the statement beyond its truthfulness. This elegant balance makes ZKPs incredibly powerful for maintaining confidentiality. For tech enthusiasts, understanding the how is key. ZKPs aren't a single algorithm, but a family of cryptographic protocols. Historically, many ZKPs were interactive, requiring a series of challenges and responses between the prover and verifier. While secure, this interaction limits their applicability in many modern distributed systems. The real game changer has been the advent of non-interactive zero-knowledge proofs, NISPs. With NISPs, the prover generates a single, compact proof that anyone can verify independently, without further interaction. This is achieved through advanced cryptographic techniques, often involving complex mathematical structures like elliptic curves and polynomial commitments. Key NSKP schemes you'll encounter include ZK snarks, ZK starks, and bullet proofs. ZK snarks, zero knowledge, succinct, non-interactive argument of knowledge, are highly efficient in terms of proof size and verification time, making them ideal for on-chain applications. However, many require a trusted setup, a one-time cryptographic ceremony that generates public parameters. ZK starks, zero-knowledge, scalable, transparent argument of knowledge, offer quantum resistance and do not require a trusted setup, making them more transparent and future-proof, though their proof sizes can be larger. Bullet proofs provide compact proofs without a trusted setup, particularly useful for range proofs, proving a number is within a certain range. Each scheme presents unique trade-offs in terms of performance, security assumptions, and transparency, driving innovation across the cryptographic landscape. The implications of ZKPs for privacy are profound. In an era of constant data breaches and privacy concerns, ZKPs offer a paradigm shift. Instead of organizations collecting, storing, and potentially exposing vast amounts of sensitive personal data, ZKPs enable a verify without revealing model. This fundamentally changes the burden of data protection, moving it from the data custodian to the cryptographic protocol itself. Imagine a world where you can prove your age to access age-restricted content without revealing your date of birth, or prove your income meets a loan requirement without disclosing your exact salary. This is the essence of self-sovereign identity, SSI, where individuals regain control over their digital identities. ZKPs are a cornerstone of SSI, allowing for the creation of tokenized identities and verifiable credentials. You could hold a digital credential issued by a trusted authority, like a government or university, and use a ZKP to selectively reveal only the necessary attribute, e.g., over 18, without exposing your name, address, or any other personal details. This drastically reduces the attack surface for identity theft and makes sensitive data far less vulnerable to breaches, ushering in a new era of digital trust. The practical applications of zero-knowledge proofs span across virtually every industry, promising enhanced security, privacy, and efficiency. Their versatility makes them a critical tool for building the next generation of secure digital infrastructure. In the highly regulated financial sector, ZKPs offer unprecedented solutions for privacy-preserving compliance and innovation. They can be used to verify creditworthiness without revealing sensitive financial data, allowing lenders to assess risk while protecting customer privacy. For anti-money laundering, AML, and Know Your Customer, KYC regulations, ZKPs enable financial institutions to confirm customer identities and monitor transactions for suspicious activity without exposing the full transaction graph or personal details to third parties. This allows for private compliance, where regulatory requirements are met without compromising individual privacy. Furthermore, ZKPs can facilitate proof of reserves for cryptocurrency exchanges, allowing them to cryptographically prove solvency without revealing their entire balance sheets, fostering greater transparency and trust in the digital asset space. In decentralized finance, DeFi, ZKPs enable private transactions and private liquidity pools, addressing privacy concerns that have historically limited mainstream adoption. ZKPs are revolutionizing identity verification by allowing individuals to prove attributes about themselves without revealing their full identity. This is crucial for online age verification, where a user can prove they are over 18 without sharing their date of birth or ID document. It extends to secure login systems where ZKPs can replace traditional passwords, offering a more robust and privacy-preserving authentication method. Businesses can confirm a customer's eligibility for a service or product without ever needing to copy or store sensitive personal information, significantly reducing their data liability and enhancing user trust. This shift from data collection to attribute verification is a cornerstone of a more private digital future. ZKPs are arguably one of the most critical technologies for the advancement of Web3, the decentralized internet. They are fundamental to solving the scalability trilemma in blockchain technology, balancing decentralization, security, and scalability. ZK rollups, for instance, batch thousands of off-chain transactions into a single proof, which is then verified on the main blockchain. This drastically increases transaction throughput and reduces fees, making decentralized applications, DApps, more usable and accessible. Beyond scalability, ZKPs enhance privacy on public blockchains, allowing for confidential transactions where amounts and participants can be hidden while still maintaining verifiability. They also enable cross-chain interoperability, allowing different blockchain networks to securely communicate and exchange assets without revealing underlying transaction details. ZKPs are essential for building a truly private, scalable, and interconnected decentralized ecosystem. The integrity and transparency of voting systems are paramount for democracy. ZKPs can be used to create highly secure, verifiable, and private electronic voting mechanisms. Voters can cast their ballots with cryptographic assurance that their vote is counted correctly and only once, without revealing their identity or who they voted for. This addresses concerns about voter privacy, coercion, and election fraud, potentially making online voting a more viable and trustworthy option in the future. Healthcare data is among the most sensitive personal information. ZKPs offer a powerful solution for privacy-preserving data analysis and sharing in this sector. Researchers can analyze aggregated medical data for trends and insights without ever accessing individual patient records, enabling breakthroughs in medicine while strictly adhering to privacy regulations like HIPAA. Patients can prove eligibility for insurance claims or access specific medical services without revealing their full medical history, ensuring that only necessary information is disclosed. This allows for more efficient healthcare operations while maintaining the highest standards of patient confidentiality. In complex global supply chains, transparency and trust are often challenging. ZKPs can enhance the privacy, security, and efficiency of supply chain operations. Companies can verify the authenticity of products, track goods from origin to destination, and ensure compliance with ethical sourcing standards without revealing proprietary business information or sensitive supplier details. This allows for greater accountability and reduces fraud while protecting competitive advantages. The proliferation of IoT devices brings immense convenience, but also significant security and privacy risks. ZKPs can be used to secure data and communications in IoT networks. Devices can authenticate each other and exchange data without revealing their unique identifiers or sensitive operational parameters. This ensures that data collected by smart devices remains private and secure, preventing unauthorized access and misuse, and building trust in interconnected environments. As AI systems become more pervasive, the privacy of the data they process is a growing concern. ZKPs enable AI systems to operate on encrypted or obfuscated data without ever needing to decrypt or access the raw information. This concept, known as private AI or confidential computing, allows AI models to be trained on sensitive data sets, e.g., medical records, financial data, while preserving the privacy of individuals. It aligns perfectly with global privacy laws and encourages users to share data with AI systems by building a foundation of trust, accelerating AI development in privacy-sensitive domains. While the potential of ZKPs is immense, their widespread adoption still faces challenges. The underlying mathematics can be complex, making implementation and auditing difficult. The computational overhead for generating proofs, especially for large data sets, can be significant, though ongoing research is rapidly improving efficiency. Furthermore, educating the broader public and regulatory bodies about the benefits and security guarantees of ZKPs is crucial for fostering trust and adoption. However, the opportunities far outweigh these challenges. As ZKP technology continues to advance, becoming more efficient, user-friendly, and integrated into developer toolkits, we can expect a rapid uptake across various industries. The future promises a digital landscape where privacy is not an afterthought, but a fundamental design principle, where trust is verifiable through cryptography, and where our sensitive data remains truly our own. ZKPs are not just a cryptographic tool. They are a cornerstone for building a more secure, private, and equitable digital future. Zero-knowledge proofs are more than just a buzzword. They are a foundational technology shaping the next generation of the Internet. If you're a tech enthusiast, developer, or simply curious about the future of digital privacy, now is the time to dive deeper. Explore the open-source ZKP libraries, follow the latest research from leading cryptographic teams, and engage with communities building privacy-preserving applications. Your understanding and participation are vital in accelerating the adoption of this transformative technology. Subscribe to our channel for more deep dives into cutting-edge tech. Share this video with fellow innovators, and let us know in the comments what ZKP application excites you the most.